Okay, so I'm going to move on to lab number two. There was another exercise in the previous lab, but it was, just kind of felt like a fairly usual exercise in like data structures and algorithms and whatnot, which, isn't exactly what I'm trying to learn here, so I figured I would just skip it. Um, Moving on to lab number two. Then, thankfully, the code can be found at this link. And so, anyway, uh, guess I'm curious. Okay. Um, anyway, okay. So we're going to implement this thing, which returns a value of type unsigned, which is an unsigned integer. And I guess, the important thing to know about unsigned integers and that type is that these operations on it are valid and sort of defined if you were to think about it in its binary representation. Left shift, right shift. Okay. So, um, yeah, I guess let's get into it. So, we are given a value x, an unsigned n, and we would like to um, return the nth bit of x. So, I think the way that makes most sense to me is that we might as well shift x uh, to the right. By the way, let's make sure that this is clear what a right shift means and so on. So I'm just going to quickly jot this down here, that if we had, let's do this. If we had, let's say x equal to 11010, and let's say that n is equal to 3. And so I suppose n should start from 0, and so therefore that would be the 0th bit. I think this is how we should write it. I think the 0th bit should be the rightmost bit, and then you have the bit in place 1, I suppose you could say, 2, 3. So that right there is what we should have as the I guess, what do we want to say, that that's the third bit, so to speak, with n equal to 3. Anyway, so then what is probably good to illustrate right now is how shifting works, right? So, I think here it's even a little clear, intuitive, that if we shifted this one way or another, but it's, especially easiest to shift to the right to get access to the rightmost digit. Um, so if we were to shift this, right, if we were to take 11010 and right shift it by 3, then that would come out equal to just 1, right? That you would basically have locked off those rightmost 3 digits and get this. Um, and then knowing that the value that we want is stored here in the rightmost digit, you can use AND to wipe out everything else, right? So basically what I'm getting at is that if you took that resulting value and you AND it with just the number 1, then that's going to wipe out, right? The 1 here together with the 1 here compute to 1. If it were a 0, then it would compute to 0. So, effectively what I'm arguing is that no matter what is here, if you AND it with 1, you keep it. But then because this is, right, or well, everything to the left of the 1 is, right, you can imagine it being padded out with a bunch of zeros, and then you and it with zeros, and you get zeros, so that you wipe out everything else. So anyway, that's the idea. So I think if we were to go ahead and implement this, then I want to take x and right shift it by n. So let's say that and x, yeah, so x, let's say and I know I'm going to eventually take x and, let's see, hold on. So I want to right shift it. So I guess, let's say, okay, so x equals x right shifted by n. And then can I say that I want to return x ANDed with 1. I think that'll work. Yep, okay, cool. So let's get into the appropriate uh, okay, so here we are, and then I suppose I want to say GCC, guess O, and then which is this? Oh, bit ops, right? So I think bit ops. Oh, and there's a make file. So can I just call make? So okay, just warning. So I guess it's okay. And then if when I eventually get around to set bit, we will resolve that issue. Return, let's say value and function return void. Oh, I see. I think I adjusted this. So okay. And then likewise here. Anyway, okay. So let's save that. Come down here. We already made, but I guess I should make again. So make again, and then I guess run Bitwise. Yeah, great. Uh, Okay, yes. Oh, good. And it even tells me things that are and aren't correct. So get bits are all correct. So I seem to have, yeah, implemented that. And then we'll need to do set bit. It's currently coming out wrong because I haven't yet implemented it. And likewise for flip bit. Okay, great. Great news. Okay, so I guess let's move on to set bit. So I guess you tell me x, which is a pointer to an unsigned integer, and you tell me n, which is in the nth place. Right, and it might be useful that we know that this is between 0 and 31, so to speak. Anyway, and then you give me a v, right, which is what we're setting it to. Okay. So, right, how are we going to do that? I don't. So a first thought is, oh, if you were given, like, let's just simplify this and say, if you were given just a single bit, call that x, and we would like to combine that somehow with V such that the result is always V. Um, well, certain, yeah. So, I mean, okay. Well, and does not do this, and or does not do this, and XOR does not do this. So I guess pretty clearly, there's no single operation that would work here. What about a more complex one, like if, how about this, X, uh, so I guess I could take X and just turn it into, like, we could turn it into a 1 and then AND it with V. Um, I guess the reason for thinking about this as a single bit is a hope that I could do this somehow coordinate wise. So, um, so how could I turn this into, yeah, I guess I was trying to think of some like more clever Boolean way of doing it, but I guess maybe the less clever, like we just basically uh, construct uh, uh, a bit of all what zeros uh, except for a 1 in the nth place, and then we yeah, that's probably the easiest, I think. So yeah, let's construct a number that has all zeros except for a 1 in the nth position. And then what am I going to do with that? Or it with X. So okay, so I think it's easy enough to get uh, a representation of the number 1. We left shift it by n. So that's going to be a number which is all zeros except for a 1 in the nth position. And then if I OR this with with whatever's at x, so I think I want to say star x gets ANDed with this, or sorry, ORed with uh, this, then I have forced the nth coordinate to be a 1. Yeah. And every other bit is left unchanged. Now that I have made it a 1, I'd like to uh, make it into V, saying, well, look, if I know that that's a 1, then if I AND it with V in the appropriate position. So if I now say X ANDed with V left shifted n times, then I think that should work. Yeah, and I don't need to return anything, so good. Let's see, did I get it? Um, let's do, I need to make, I need to run, and nope, that is not it. What am I missing? So, So I take 1, I left shift it by n, uh, and then I OR x by every, right, in every coordinate other than n, it is ORed with 0 and therefore left unchanged. Oh, interesting. Huh. Looks like a lot of things got turned into zeros that I didn't want turned into zeros. Um, hmm. Anyway. Um, oh, right, of course, because because I'm taking V and all I'm doing is I'm right shifting V, so that's putting a bunch of zeros in a bunch of places, uh, so that when I AND it with a bunch of zeros, then it's just wiping out a bunch of points, so to speak, or coordinates. Okay, so then I want it to be ones everywhere except where V is at location N. Um, hmm, yeah, left shifting and such gets you. Okay. A little, maybe a little messy, but I guess it is doable that we could perhaps take uh, V left shifted by n minus 1. Is that a good idea? Maybe we'll take. hmm, hmm. Okay, well, this is seeming tough, and I'm sure there's a way around it, but maybe it's better if I uh, instead of ORing with a 1 in that position, it might be better if I had instead ANDed with the inverse. And so what I have now done is taken the number that has what ones everywhere and a 0 in the nth position. I'm anding that, so I've now forced the the nth coordinate to be 0, and now um, I would like to OR the nth position with V left shifted by N, right? Because if it's a 0 and you OR it with V, then no matter what V is, it sort of absorbs the value. Okay, cool. So let's go ahead and make and run, and now it's correct. Okay, cool. Okay, and then let's flip the nth bit only. Okay, so flipping, um, how do you flip? Um, Intuitively, that would be like negation, but you only want to get the bit at coordinate n and flip that. And I guess we could get the nth bit. Uh, Negate it and say, oh, we could do that. Yeah, okay. We could like put the two previous things together and say what that uh, x should. So let's see. So we want to set bit of and then let x uh, n, and we would like to make it not and x, or let's say get bit of and x at coordinate n. Cool. Will that work? Oops. Hmm. Oh, right. I don't want and because that gets you the address. I want star because that gets you the reference. Hmm. Set and get are correct. So set x a coordinate n to the value of but by negating it, right, because it's not just a single thing. What if I did one minus to represent negation rather than, right, because negating, induces ones in all kinds of various locations. And now it works. Okay, cool. Um, Whereas, right, if you just do one minus, right, like if this is already either a 0 or a 1, then 1 minus whatever one that is will get you the appropriate value. So, okay, cool.